AI agents are everywhere. Applications such as Ask Perplexity and Grok are helping thousands of people to get immediate answers to thousands of questions. You can ask questions about any topic, anything besides blockchain. If you ask any blockchain related question to these models, they are not capable of giving you an answer. So, in today's video, we're going to be building an AI agent capable of answering any question about any transaction happening on almost any EVM compatible blockchain. This AI agent is going to be connected with Tiweb Nebula services and tools. And all of that is going to be linked to a Twitter bot we are going to be building from scratch, which is going to be able to automatically answer when your username is tagged. So go and get a cup of coffee and get ready, because we are just getting started. Let me break down today's project. First, we are going to build an AI agent using ChatGPT o4 Mini as the base model. We are going to connect that with Tiweb services, allowing us to have the tool execution from Tiweb AI. Then we are going to create a new agent, which is going to be the responsible for the creation and formatting of the Twitter threads. Finally, we are going to build a Twitter bot from scratch, which is going to be able to automatically answer if your username is tagged with any of these blockchain related questions. And by the way, for those of you who don't want to spend money on ChatGPT API keys, well, I'm going to also show you how you can run this locally using Ollama models and DeepSeek R1. So without further ado, let's jump to the code. There are a bunch of tools and frameworks out there to build AI agents, such as Coinbase Agent Kit, Llama Index, LangChain, but today we are going to be using Pydantic AI from the same people from the Pydantic library, which is already used from most of the large language models as a data modeling library. Pydantic AI is really good because it's going to allow us to build really customizable AI agents with a lot of functionalities such as function calling, grabs, and multimodals, including the compatibility with MCP servers or the Model Context Protocol. As you are about to see, building an AI agent using Pydantic AI is going to be really easy. And for this tutorial, we are going to be also using UV Python Manager, which is going to be amazing to manage different Python instances and all the dependencies we are going to need for this specific project. So let's get to it. Let me go to my terminal, and here I'm going to create a new UV project with UV init. Let's create a virtual environment with UV BNB. Let's activate this. And here we can install all the dependencies we need. Interestingly enough, for this tutorial, we just need to install one simple package. We can use UV add Tiweb-AI, the Pydantic AI modifier. Let's hit enter. This will install all the dependencies needed for our project. Let's clear the terminal and let's open our code editor. I highly recommend you to use Cursor because with all the AI assistant tools, coding this is going to be really easy. Let me hit enter. Let me open this and let me go to main.py. Let me remove actually this, and we are going to create a basic py. Let's import some libraries, asyncio for asynchronous calling and import us for getting the environment variables. Then I'm going to say from Pydantic AI, let me import agent. And from Tiweb AI, I'm going to import Insight and Nebula. Then we need to import the adapter for Pydantic AI. So from Tiweb AI adapters, let me import get Pydantic AI tools. Then we need to declare the variables for Insight and Nebula. So I'm going to say Insight is equal to Insight, and we are going to be using the Tiweb secret key. This is an environment variable we don't have already. So let me create a new .env file and add this as environment variable. And here you need to add your Tiweb environment variable. Take something in consideration. I'm using .env right now because this is just for developing purposes and because it's easy, but always be sure to encrypt that information to never expose your API keys. With that said, let me declare a main functionality, async def main, and here I'm going to say this is an example of a basic agent. I'm going to say that the tools this agent is going to have is going to be the get Pydantic AI tools, and I'm going to say Insight and Nebula, but I'm going to get the tools for each one of those. So insight.get tools, and the same is going to be for Nebula. Then I need to declare the agent, so I'm going to say agent equals to agent, and the model is going to be ChatGPT o4 mini. The tools are the tools I'm sending here, and this configuration actually I'm not going to be using, but I'm going to declare here a system prompt. By default, it's telling me you are a helpful assistant that can answer questions and help with tasks. Your assistant to get information out of the blockchain and transactions. And of course, in order to make this work, we need to have an OpenAI API key with some funds on it in order to be able to interact with the API and to interact with this model. So for that, we will need to also add an OpenAI API key. Now, I mentioned at the beginning of the video that I'm going to show you how you can also run this using local models using Ollama if you don't want to spend money with ChatGPT. So I'm going to also show you that right now. Let me go back to the top and let's make some imports here. So I need to import here from Pydantic AI models, the basic OpenAI model and the basic OpenAI provider. And I know it's OpenAI, but this is actually going to be useful for the Ollama model. So I'm going to declare here Ollama model. It's going to be equal to an OpenAI model. I know the naming here is confusing. We need to set up the model. Instead of using this, I'm going to actually be using MFDoom DeepSeek R1 with tool Kalin, the version with 8 billion of parameters. Take something in consideration here, and is that the better the model you are going to run, the better is going to be the responses you are going to also get. So be sure the model you are running here is capable enough of first have tool calling and second to have enough parameters to be decent enough. I highly recommend you keeping with the ChatGPT o4 mini because this is going to give you consistent answers, and if you want to go one step further, you can also use Cloud API and use Cloud 3.7 Sonnet, which is the best, but at the same time is the most expensive one. So with that said, let's continue. So let's suppose instead of using this model ChatGPT o4 mini, you want to use the Ollama model. The only thing you would need to do is to copy this and paste it over here. And you are going to be able to use this as the model for this AI agent. For this video, I'm going to keep using ChatGPT 4.0 mini though. And by the way, if you didn't have ever used Ollama before, be sure to first download Ollama and be sure to have the actual model you want to run already downloaded. You can install a new model simply by calling Ollama run and the model name you want to run. Also, a small recommendation for those of you wanting to use this instead of ChatGPT, and is that I've used this DeepSeek R1 tool because it has tool calling, but you can also use the Llama 3.1 of 8 billion of parameters, which has demonstrated to be good enough for this specific use case. Let's go back to the code. Now that we have the agent declared using ChatGPT o4 mini and all the tools from the Pydantic tools, I'm going to just make a print of all the available tools so I can understand what the tools are about. And then we can send a sample query. So for example, I can say that this list of queries is going to have just one question, is what are the addresses associated with tirweb.it? So this should be able to resolve this ENS domain and give me the actual address connected with this tirweb.it. Now let me create a simple query. So I'm going to say for simple query, I'm going to say for query in queries, I mean for each individual query on this list. I know I'm just adding one, but you can add a lot of queries just for testing purposes. I'm going to print the query and I'm going to say result is going to be equal to await. The reason I can use await is because we imported asyncio. And I'm going to say agent.run and the query I'm sending over. And of course, I'm going to be also printing the result. And finally, let me create the main function here. So I'm going to say if name equals main, please run the main function with asyncio.run. And as easy as that, we have everything we need. Of course, don't forget first fill up the information of your API key from OpenAI and your Tirweb secret key. Getting your Tirweb API key is going to be really easy. You just need to go to your Tirweb dashboard and inside of the project settings, you're going to have the secret key over here. Of course, if you have forgotten the secret key, please generate a new one over here. So after you add that to your .m file, I think we are ready to test this out. So let me actually run this and let's see what happens. Let me hit on the run button here. This is going to run this basic model. With the OpenAI key and the ThreadWeb secret key, we can run this. So let's click on run. And it seems like getting a problem with the declaration of the OLAMA model. I can safely delete this because I'm not going to be using it, but I already see the problem here is because I'm requesting an OpenAI API key here, which is incorrect because this is running locally. So instead of using the OpenAI provider, we can check the documentation and it seems that the provider should be declared like this because of course this is running locally. So let me copy and paste that over here. And I think this is going to solve our problem. Paste this over here, and instead of model, we need to actually use model name. So let's try and run this again. This is going to list all the functions for me. We have the ability to get all events, all transactions, all ERC20 tokens, to chat with the Nebula service, and so on and so forth. And as you can see, the model already gave me the response I wanted. The query was, what are the addresses associated with ThreadWeb.it? And the result is the ends domain for ThreadWeb.it is associated with the following Ethereum addresses based on the recent transaction and this bunch of addresses. These addresses are involved in various transactions, with one address being a common recipient associated with the ThreadWeb platform. If you need more specific details about these addresses and transactions, feel free to ask. And as this is that, we have created a basic AI agent, which is using, as I said, ChatGPT o4 Mini as base. We declare the agent, we create a basic system prompt. You are a helpful assistant to get information out of the blockchain and transactions. And then we directly call the query, what are the addresses associated with ThreadWeb.it? How ChatGPT o4 Mini was able to get that information? Well, the answer is kind of obvious because we have imported ThreadWeb AI and the tools from Insight and Nebula. And as I said before, I'm printing all the tools, and if we check the terminal, give me a second, we are going to say that here we have all the tools available. And as this is an AI agent, the AI agent should be capable enough to understanding which tool execute on each specific case. We are not supposed to tell, hey, execute this or this, but the agent should be good enough to decide which tool it wants to use each time. Okay, so we have completed the first step. We have created the AI agent and we have connected that with the tools from ThreadWeb. Let's continue. So as it is now, this agent should be good enough and intelligent enough to decide which tool to use on each specific scenario, right? And that's true. However, sometimes you would like to actually specify the tool the AI agent needs to use. This is specifically important for you to avoid data inconsistencies, and also because sometimes the models tend to hallucinate and might not use the exact same tool you need them to use. This is specifically problematic if you are using a model running on your machine, such as a Ollama model, because they are most of the times not as powerful enough to compete with the OpenAI models or the cloud models, especially if your computer is not that powerful. So I'm going to show you how you can declare your own custom tool for this agent. We are going to be addressing the specific tool we want for this video. Remember, I told you we want to create an agent which is going to get the information about any transaction happening on any event compatible blockchain. So we are going to create a tool which is going to address specifically that scenario. And finally, for those of you who want to get more control out of the output data, I'm going to show you an optional file which is going to have the exact same model, though this model is going to use Pydantic based model, which is going to allow you to have a really structured output out of each query. With that said, let's go back to the code. Okay, so first let me show you what happens if we change the query we are sending here to this one. Can you analyze this transaction and is on the base blockchain? Let me run this. It's going to list all the available tools again. And after some time, it's actually giving me the specific details for this transaction, the transaction hash, the block number, the block hash, etc., etc. Now, does this mean that this is going to consistently work over and over again? I'm not sure about that. Let me remove this and try and run this again. And as you can see, just on the second run, this already failed. And my guessing here is that as I'm sending base, as text and not the actual chain ID, which is required by the tool get all transaction details, sometimes the model is going to decide, okay, I'm not going to transform this information into actually the actual chain ID, which is problematic. Let me close this and try again, and this might work or might not work again. And as you saw, this time it worked. The problem is we cannot rely on this to work when it wants and don't work when it don't wants to work, right? We need to ensure that when we send this information to the Nebula service and Insight service, is going to always give me what I want it to give me. So for that, let's create that custom tool I told you about. Let me close this, and here I'm going to make some refactoring. So instead of using this main function over here, I'm going to refactor this to have a initialize service function, which is going to do the exact same, but is going to return inside Nebula an agent. The reason I'm doing this is because now that we initialize the service, we can start adding new tools to this specific agent. And adding a tool is really easy. For example, I just need to use the decorator agent.tool and the name of the tool, analyze transaction. So I'm going to say here def analyze tx, and we are going to send the context, which is going to be the run context. I haven't told you what this run context is. Basically, if we are using this agent with different tools and one tool does something and then it needs the information, we need that context in order to proceed. So you need to use this run context from Pydantic AI. So the context, and I need to send the transaction hash and the chain ID. Now I want to analyze the transaction to get the raw transaction data, and here is trying to use get transaction details. Let me open this, and it seems that get transaction details requires a str of the transaction hash and a list of integers or strings for the chain ID. In this case, is going to default to 1 to Ethereum. So as this is the requirements I have for the model, I'm going to erase this completely. And here I'm going to say params equals to chain, if not is instance chain ID list, else chain ID. Let me actually show you what this code is about. So basically, this line is creating a dictionary of params with the key chain that will be used specifically for the blockchain network. If instance checks if the chain ID already exists. If the chain ID doesn't exist, it's going to create a new list and it's going to map. For example, for chain ID is going to be Ethereum, 137 is going to be Polygon, etc., etc. This is important because the Insight API expects the chain parameter to always be a list, even when querying a single chain. This line ensures that. And this is true because, as we saw, this is a requirement directly from the Insight. So with that said, I can say return insight.get f. I'm going to use resolve, which is another tool, the transaction hash, and the params. Let's save this. And let's run this and see if this works. Of course, the query is not going to change because the agent should be intelligent enough to know that right now I want it to use these specific tools to analyze the transaction, because I'm specifically telling it analyze this transaction. And as you can see here, it seems that it works properly. Now, the thing we need to do is actually run this over and over again and trying to understand if this is actually consistent. I already did this, and for all my tests, this is working properly each time I run it. So basically we address that right now. This is going to use the analyze transaction, is going to address the formatting for the chain ID that, as I showed you, requires a list on a specific format. And then we are going to call the resolve tool with the transaction hash, this transaction hash, and the params, which are going to be this chain, but transform it into a list. As I promised before, I wanted to show you a different approach to this using base model. So let me show you that. I have here another file called Pydantic Agent Simple. It's the exact same as before, but right now you can see we have a lot different data. So basically what you do when you use base model from Pydantic is you declare a class, which is going to be the transaction data. Inside the class, you define all the output information you want. For example, transaction hash, block number, timestamp, from address to address. I make all of these fields and they are optional because sometimes depending on the transaction, you are not going to find these fields. And you have a description for each field, the amount of gas used, the amount of pricing waste, etc., etc. Then when you declare the tool, instead of just asking it, it's going to, again, take the chain ID, use the resolve tool, but then it's going to try and format that based on this transaction data. So basically what it's doing here is taking the transaction data, using the transaction hash and the transaction result, is going to extract the commonly used fields if they exist. It's going to, again, trying to format everything. And at the end of the line, this is going to give me a similar response as this one over here, but this is supposed to have more structure on the output. Let's test this out. It's going to be the exact same query. Can you analyze this transaction? Let me run this. And as you can see here, it formatted it on a specific way. This is not that different from the original one because the information is almost the same, but using the base model, you can format the information on the way you want. If you want a more advanced tutorial on how to apply base model to building AI agents for blockchain, let us know in the comments below. With that said, let's continue. Okay, so at this point, we have created the basic agent with OpenAI. We have connected that with the Pydantic tools provided by Tirweb, and we have created a custom tool to solve the transaction information, which is nice. Now, let's continue with the part of creating the other agent, which is going to be the responsible for creating the Twitter threads. So let's get to it. So here I have another file called thread creator, which is empty, and let's get started by importing some stuff. I'm going to import base model, agent, OpenAI provided, and the wrong context. I'm going to define a class called Twitter thread, which is going to just return me 3 simple strings with the tweet 1, tweet 2, and tweet 3. And same as we did before, I'm going to declare the Ollama model and the agent. We can interchange these from Ollama and OpenAI 04 Mini. Actually, we are going to interchange these later to see which one of these give us a better result. And then let's define the function. So I'm going to say async def generate Twitter thread. This function is going to return the same class model we just defined, the Twitter thread. And inside of here, I need to do something. First, I'm going to create a prompt, same as we always do. And inside of this prompt, I'm going to request some stuff happening. So this is one of the most important parts for this script because the results we are going to get are going to be as good as our prompt. So let me copy and paste the prompt I have created for this. I was tinkering with this a lot, and this is the best prompt I came up with. Write a Twitter thread with the data. I'm not sending the data. Actually, I'm going to say the data is going to be the data I'm sending here. In exactly 3 tweets, the data is about a transaction on the blockchain. You must always follow the instructions. By the way, I need to add a F here for the data to be accessible. And these are the requirements. No using Markdown, natural language, natural form between tweets. I'm also sending what's the format I'm expecting and a sample result over here. So now that we have the prompt, I can try to run this. So I'm going to say result equals to await agent.run and the prompt. And I'm going to actually print the result.data. And I think that's it, at least for now. Now let me define the main function, extendDef main. And here I'm going to say that the data, and the data is something that we need to put here. I'm going to just copy and paste the data we got from the other agent with this transaction information. As this is for testing purposes, it doesn't matter if we always use this data, because at the end, when we are executing this live, this data is going to change constantly based on what the agent provides to us. And I'm going to say that the new thread is generate Twitter thread. I'm going to call the generate Twitter thread, and I'm going to call that function with asyncio, but I haven't imported asyncio, so import async.io. And let's run this and see what happens. And it seems I have missing an await here. So I'm going to accept these changes. And yes, as this is an asynchronous function, of course I need to use await in order to execute this. Let me run this again. And take in consideration that right now we are using Olama model, so it's going to take a little bit longer than when we use ChatGPT because this model is running locally. And as you can see here, this is the response we are getting from the agent. Tweet 1, there are the details of the transaction with this hash. Tweet 2 and the details, and then we have this link with the block hash. As you can see, we have some stuff here. You know, these symbols over here, these are not supposed to appear. This must be simple text, but it seems that at least it's not using this markdown format anymore like this one over here. Now, take something in consideration. Right now we are just printing this result, but we need to return this result in this format in 3 simple strings for the tweet 1, tweet 2, and tweet 3. This is pretty important because these simple strings are the ones we need to use when we run this on the Twitter bot or elsewhere. So for that, we need to add some Python magic to make sure that this result is as clear as possible. So for example, in order to address that problem I have with this strange symbol over here, I'm going to also remove this. So I'm going to copy this over here, paste it here, and remove it from here. And this should give the model clear indications that I do not want to use these special characters. Let's execute this again. And we still have the problem, you know, we still have this strange symbol over here that we don't want it to have. Also take in consideration something. Right now we are just printing this, and let me actually print the type of this data. Type of result.data, and I'm sure this entire thing is going to be a giant string, if I'm not mistaken. And as you can see here, yes, this entire response, this entire thread is just a giant string. But as we need to respond with 3 different strings and we need to clean the information as much as possible, we are going to apply some Python magic here in order to make this possible. So first and first, we need to split the tweets and make them 3 different ones. So first I'm going to say the route text is going to be the result.data instead of printing it. And then I'm going to take that data and I'm going to split it. Basically, I'm going to find from the word tweet and I'm going to split it to have 3 different tweets. Then I'm going to append to the tweet if the tweet already exists, and I'm going to clear the output. Basically, I'm going to remove all that markdown symbols. So far, even the response didn't give me these symbols. We are not sure that that's going to be the case always. So I'm going to also address that, telling that I want to remove these symbols, and these symbols to make the information to be as clean as possible. Then I need to ensure that we have exactly 3 tweets and no more. So I'm going to say that while the clean tweets are less than 3, I'm going to keep appending this. And finally, as I already have this information, this giant string of information split it on 3 different tweets and the information clean up, I can actually make this return call. Return Twitter thread equals to tweet 1, clean tweets, tweet 2, etc, etc. So now that this is true, I can go back here and instead of saying this, I'm going to say thread equals to await.generate thread, sending the data, and I can print each individual tweet. If this works properly, let's check this out. So let me actually run this. Let's wait a little bit. And as you can see here, we have the clean tweet. We got some data to share with you, hash of the transaction with information, transaction details, value, and the transaction type, including the Explorer or the link to the Blog Explorer. This is nice. Now, let's see if there is any difference if we, instead of using the Olama model, we use the ChatGPT one. So let's save this and give it another try. And it's actually giving me the response, but not with the format I wanted. It seems that in this specific scenario, using the Olama model works better than using the OpenAI model, which is kind of interesting to see actually. Let me run that again just for confirmation that we are not hallucinating here. And as you can see, yes, we have first tweet, second tweet, and third tweet. This is amazing. Okay, so right now we have the basic agent connected with Web. We have the second agent in order to create the threads. And now we just need to put that together and create our Twitter bot. So let's jump into the last part of this video. Okay, so to set up our Twitter bot or Xbot, we need to create a new project under the developer portal. Let's click on create project. Let's select a project name. In my case, it's going to be as Nebula project. Let's click on next. We need to select the use case. It's going to be a bot. And here we need to fill up some nice description. I'm going to say this is a bot for educational content. Be sure to add a nice description to your actual dApp here. Let's click on next. And here we need to set up an app name. I'm going to say Ask Nebula app. Let's click on next. This is going to generate for us these API keys, API secret and bearer token. I'm not going to paste this because we are going to generate this really soon. I'm going to hit on app settings. And the reason we are going to generate this is because it's a really good practice to regenerate the keys each time you change the user authentication settings, which is exactly what we are going to do now. We need to set up these authentication settings in order for the bot to be able to interact with our account and create tweets on our behalf. So I'm going to change the permissions to read and write. I'm going to select web app, automated app, or bot. The app info, as we are not going to be redirecting this to anywhere, I'm going to just select the X-Men webpage. Let's click on save and let's click on yes. This is going to give us a client ID and a client secret. Be sure to copy this into a safe location and never share this with anyone. Let's click on done. This is going to also give us the OAuth 2.0 client secret. Let's also copy this. Take in consideration that we are not going to be using all of these keys during this project, but it's a good practice for you to always store this securely. Let's go back to the keys and tokens, and here I'm going to regenerate the API key and secret and the bearer token. And I'm going to do the same with the bearer token, so yes, regenerate. As I said, we are not going to be using all of the generated keys here, but the one we are going to actually be using is the access token and secret. So let's click on generate, and let's copy and paste this as well on a safe location. And that's it. That's everything we need from the X developer portal. We can go back to the code. Now that we have all of that API keys for the Twitter access, don't forget to add them all on your .m file, the access token, the Twitter API key, and the bearer token, because these are the ones the bot is going to need in order to function. So let me create another file here on the project called TwitterBot. And let's get started. The library we are going to be using for this is Tweepy, which is the best library for creating Twitter bots using Python, but I haven't installed that yet. So let me go back to my terminal and say UB at Tweepy. And as it says that, we already have it. We are going to be using load env to load from the .m file, import those and import time. The first thing we need to do is to load from the .m, in order to get the access to the Twitter token, and then we are going to declare them all: the API key, the secret key, the access token secret, and the bearer token. Now we need to authenticate, so I'm going to create a new client with Tweepy, which is going to be using that API keys. So client equals to tweepy.client and use all of these over here. Now I want to test this out in order to understand if this is actually, doing something. So I'm going to just include this function to post a tweet, def post tweet, tweetx, client.create tweet, and the tweet equals to the tweet text. I'm going to say that my tweet is going to be hello world. And let's run this and see if this is actually correct. So let me run this. And it seems worked fine. I don't know if that's true, so let's check it out. And as you can see here, I'm using this account Ask Nebula, and we have this hello world. So, yep. As easy as that, we created a Twitter bot capable of posting tweets in our behalf. Of course, we want to do here is to listen from when people tag us with a specific query and then use that query, to create a Twitter thread. So I can start adding functions manually over here, but I have another idea. As vibe coding is really popular nowadays, what I'm trying to do is that make this bot to actually use the other two agents I already have. So for that, let me select the entire code here, add that to the context, go to the thread creator and also add this to the context, and go to the basic agent and also add this to the context. which is nice. So I'm going to say here, first, let's select the best model we can, which is going to be Cloud 3.7 Sonnet. And I'm going to say, I want you to modify the Twitter bot to use the basic agent and the thread creator. When someone tags account, the bot should use the basic agent to get the information out of the blockchain, calling the agent. Then we need to use that response on the thread creator to generate the actual thread. And finally, return the response as a thread to the user. I want to add more directives here. The first one is, I don't want you to modify the agents. You must use the tools the agent have. And also, I don't want the bot to listen to historical mentions, just the latest one. I'm asking this because if our account has a lot of mentions and we run this, it's going to look from all the mentions and try to answer that. So I want just the latest one. So I'm just going to say just the latest one. And if there is no recent mentions, it will try again 15 minutes. Let's send this and see what happens. So basically what it's going to do is start modifying this in order to integrate both the basic agent and the thread creator. Let's see if that's true. So it made these changes over here. So I'm going to check what it did. It's importing the agent from the blockchain agent and the Twitter thread from the other agent. Is adding this post reply function. It's going to get the recent mentions. And it seems that it's limiting to the most recent 5 mentions, but I don't want 5, I just want the latest. Extract the transaction hash. This is going to be for taking the transaction hash from the Twitter response, from what the user is sending over. Extract the chain and doing some stuff. But this extract chain and extract transaction are actually not needed because our agent is supposed to be capable of handling this. So I'm going to save the changes, but I'm going to say we don't need to extract any information like the transaction hash or the chain ID. The bot must use the exact same text used on the mention and let the basic agent to decide what tools to use with that information. I'm doing this because basically I don't want this to start formatting what the mention information is. Our agent is supposed to be intelligent enough to have contextual knowledge in terms of we don't need to do this specifically, but just let the user to ask whatever they want to ask. So let me save the file. And I think we have this. We have process mention is going to create a result with the information. So, okay, wait, blockchain data, blockchain agent.run, mention.test. The text data is going to be the result.data. Then it's going to use that data on the generate Twitter thread. And then it's going to post the replies tweet 1, tweet 2, and tweet 3 with that information, it seems. Okay, it seems that this is going to start working properly. I'm still worried about the mentions. I'm going to say finally, I don't want the latest 5 mentions, just the latest. And just as reference, because I don't want the bot to answer anything on execution. This should work only for further mentions. And let's hit send. I modified the tutor bot to fetch only the latest mentions and skip processing on first execution, processing only the new mentions that arrive after the bots start running. So basically it's going to change this from 5 to 1, and also it's changing this to make them never just answer right away, but just for the newer mentions. So I'm going to accept this code and see if it is actually going properly. So let me run this. This is going to start running, and it says that max result query parameter value is between 5 and 10. Okay, I think that the max result should be at least 5, not just 1. I'm going to add this to the chat. It seems that their results should be 5 at least, but just add this to complain, but keep it ignoring the mentions and just listen to new ones. This is interesting about vibe coding, is that in differentiation to the rest of the tutorial in which I give you, you need to do this, and this. Right now, I'm creating this on the go with you and watching what the artificial intelligence is giving to us. So I'm going to click on accept. Of course, I'm going to review this code. So basically, it's going to change this and modify it again from 1 to 5, and it's going to keep ignoring the mentions. So accept. Let's try to run this again. And seems that we have too many requests, and you are maybe wondering why we have too many requests. The reason is because we already requested these ones on the last execution, and right now is not allowing us to do this. The main reason, let me show you. Let's go to Twitter developer portal. And on the developer portal, we are going to see that on the red limits on the free account, on the free version, if we check for mentions, it seems that we just can just make one request each 15 minutes. So we have two options for testing this out. First, wait those 15 minutes and just try again with this new modification. But what if in 15 minutes when I run this is going to be also have any problem or error or whatever? So for that, I'm going to do a little workaround for this video, or we are going to cheat a little bit on this video. Don't worry, because I'm going to leave also the code of the cheat here. So for that, I created this script which is going to allow me to directly answer to a specific post with its own ID. So basically, instead of waiting those 50 minutes, I can directly answer a Twitter post over here. So let me showcase you how this might work. Again, this is going to be on the description of the video, but let me go back to profile on X. Let me hit on post. I'm going to ask, hey, ask Nebula, can you analyze this transaction? And this is on base. Let's click on post. And this is going to give me this post ID, which I'm going to use. So let me go to my cursor and let's run this direct query.py. This is going to ask me, enter your question to the blockchain. I'm going to ask the exact same, ask Nebula, can you analyze the transaction? It's going to request me for confirmation. And here is going to tell me, do you want to reply to an existing tweet? Yes, I want to do so. And I want to reply to this exact tweet. I'm going to hit enter. And it's asking me if I want to post this to Twitter. And I'm going to say, yes, I want to post this to Twitter. Let's hit on enter. It's going to send the query to the basic agent. And then with that response, we are going to generate a Twitter thread with the thread creator. Let's wait a little bit until we get a response out of here. So it seems that it received the response from the base model agent, and now it's generating the thread. And it seems that it created a post for me. So let me see if that's actually true. Let me go back to the browser, and it seems we have a new comment here. Let me actually reload the page. And here I'm going to have this. So I have this thread. There are a blockchain transaction with this hash from block to block. And it seems that it's asking me to view it on the Blog Explorer, but the Blog Explorer is incorrect. And this is exactly where I said that sometimes using ChatGPT or an advanced model is better, because they are going to be able to answer this properly. So what I'm going to do actually is go to profile here. By the way, if you haven't followed Ask Nebula, do it, because for this demo, we are just creating this part of answering specific queries about transaction data, but we are going to be adding a lot of functionalities and you are going to be able to use this as it was any other agent. So I'm going to go to the replies and I'm going to delete these replies because I'm not sending correctly the block explorer, which is a shame actually. So let me erase everything here, and what I'm going to do is go to my model over here. So one thing I can do to improve this and ensure this is giving me the correct addresses is that here I can add to my prompt to generate the thread, like be sure to use the correct block explorer link for the chain. This is the list of the most common ones. And I'm going to use this Ethereum Basescan, Polyscan, Arbitrum y optimistic.etherscan.io. Also, let's avalanche, and that's all of this, for example. So as I already have this is the correct answer, for example, for Basescan. So let me save this and let's try again. So let's go to direct query, let's run this, and let's try again with the exact same question. I'm going to be answering to an existing tweet. So let me copy again the post ID, paste it over here, and I want to post this on Twitter. Yes, I want to post this on. Let's hit enter. And it's going to go through the exact same process, but right now I'm trying to ensure the model is actually using the format I wanted to. Also, I've changed the way the thread creator processes stuff, so I'm using ChatGPT O4 Mini right now instead of the old Llama model. It seems that it actually gave me another link, which this one should actually work. Let's test this out. Let's go to the Brave browser, reload the page. We have the response, so analyzing the transaction hash. We have the information on, oh, we have this link and it's actually working and we have the detailed information. So this is amazing. We have now the ability to answer direct posts on Twitter using our account and sending these queries to the AI agent. The AI agent is going to get information from Tierweb, Insight, and Nebula. Is going to return that information, which is going to be used with the other agent, the thread creator, and that's going to format everything for us to be able to post this as a Twitter thread. Also, don't forget that even though we are using this direct approach just for testing purposes, what you should actually do is go to the Twitter bot and actually run this. This is going to check the latest mentions. So for example, the initial mention ID recorded in this one will only process new mentions. And again, it's going to give me this error 429, too many requests. And the reason is because, as I said, the rate limits on Twitter right now is just one review of mention each 15 minutes, which is a bummer. But if you want to apply this for your own protocol, game, or application, you might consider paying for the basic plan, which is $200 a month, which is kinda expensive. To finish this video, I want to tell you that this template is for you to tinker with and see what you can accomplish, but don't forget to go and follow the Ask Nebula account on X. We are going to keep updating this bot and we are going to give it full functionality, so you are going to be able to ask any question about any EVM compatible blockchain. That was it for today's video on my end. I hope you enjoyed this video. Don't forget you have the link on the template on the description, and I'll see you on the next occasion. See ya!